presentation with introduction of soil compaction. Okay, so what is soil compaction? Soil compaction is the practice of applying mechanical compactive effort to densify a soil by reducing the void space between soil particles. Compaction occurs when particles are pressed together to reduce the space between them. Soil compaction is necessary to increase the bearing capacity and stiffness of in situ, or we can call it natural state, or chemically modified soil. Compaction can increase the shear strength of soil by adding friction from the interlocking of particles. Future settlement of soil is reduced by increasing the stiffness and eliminating voids, creating a densified soil. The removal of void will reduce the chance of soil setting or shrinking or expanding, and it also helps in decrease the water seepage that will lead to deleterious shrinking and swelling soil properties. Shrink or swell properties compromise the pavement structure, thereby leading to premature failure of the pavement structure. That's all from me.
Assalamualaikum. My name is Nurzai binti Zulkifli. My matrix number is AF200068, and I want to present about literature review in this report. So in this case, our group will elaborate on the application of soil compaction in highway construction. As we know, soil compaction in highway engineering is required starting from earthworks for pavement preparation to road surface construction. For example, when the preparation of earthworks, the soils will be compacted using rollers after the excavation works. Next, in the surface preparation, compaction of soil is applied to reduce the volume of air in N-hot mixed alphage HMA mixture using external forces to reorient the constituent aggregate particles into a more closely spaced arrangement. Hence, compaction is the greatest determining factor in dense graded pavement performance. That's all for me.
Warahmatullahi wabarakatuh. Today I'm going to present about applications of soils compaction. Mechanical properties of compacted soils. The structural safety of the roadway is governed by the mechanical properties of highway subgrades under the dead load of the pavement structure and the dynamic loads produced by vehicles. The instantaneous elastic reaction as well as the time-dependent viscoelastic and viscous response of the subgrades can be examined by analyzing the viscoelastic nature of the soil. There are many basic forms of static and dynamic loading patterns, and it is conceivable to explore the interrelations among the viscoelastic function on a phenomenological level if the behavior of the soil.
Assalamualaikum, my name is Kairin binti Khairil Anwar. I would like to present about the theoretical study of the soil compaction. Compaction means pressing of the soil particles close to each other by mechanical methods. Subsequently, compaction may be defined as the process in which soil particles are forced closer together with the resultant reduction in air voids. In this process, air is expelled from soil mass and mass density is increased. It is done to improve the engineering properties like the strength, stability, and reduce compressibility and the permeability of the soil. As you can see in the figure, there is a soil compaction effect on the soil. In the construction of highways and other engineering structures, loose soil must be compacted to increase the dry unit weights. To compact a soil, that is to place it in a dense state. The dense state is achieved through the reduction of the air voids in the soil with little or no reduction in the water content. This process must not be confused with consolidation, which is different from compaction. Consolidation means water is squeezed out under the action of continuous static loads. Hence, the strength characteristics of soils is influenced by the compaction, which increases the bearing capacity of foundations constructed over them. Compaction also decreases the amount of undesirable settlement of structures and increases the stability of slopes of embankments.
Compaction is the process by which the bulk density of an aggregate of matter is increased by driving out air. For any soil, For a given amount of compaction active effort, the density obtained depends on the moisture content. At very high moisture content, the maximum dry density can get when the soil is compacted to nearly saturation, where almost the air is driven out. At low moisture contents, the soil particles interface with each other and addition of some moisture will allow greater bulk densities, with a peak density where this effect begins to be counteracted by the saturation of the soil. Soil compaction is necessary to increase the bearing capacity, stiffness of a natural state or chemically modified soil. Compaction increases the shear strength of soil by adding friction from interlocking of particles.